Hello, everyone. Today, we are embarking on a journey to the surface of Mars, exploring the Jezero Crater in search of signs of ancient microbial life with the Perseverance rover. Is there life on Mars? This question has intrigued scientists for centuries, and now we might be closer than ever to finding an answer. Imagine, billions of years ago, Mars was a place where water flowed on the surface, with lakes and rivers. If this is true, could we possibly find traces of microorganisms that lived on Mars at that time? This is where Jezero Crater comes into play. An ancient lakebed and delta system, this crater is the perfect place to search for signs of ancient life. Perseverance rover has landed on Mars and is exploring Jezero Crater, looking for these ancient microbial traces. With its advanced scientific instruments, it analyzes the rocks and soil of Mars, searching for organic molecules and biological markers. If we can find these traces, we will not only learn that life once existed on Mars, but also gain new insights into the origins of life on Earth. If you're ready, let's delve into the exciting exploration journey of Perseverance. We'll discover what might be found in Jezero Crater, the tasks of Perseverance, and the scientific significance of these discoveries. Ready to uncover the secrets of Mars? Let's get started. Why Jezero Crater? With so many craters on Mars, why was this one specifically chosen? Let's explore why Jezero Crater is so special. Jezero Crater is about 45 kilometers in diameter on the surface of Mars. Billions of years ago, this crater contained a large lake and delta system. Yes, you heard that right. At one time, there was water in this region of Mars. This water, sustained by Mars's ancient atmosphere, created ideal conditions for life. Scientists believe that Jezero Crater holds the remnants of this ancient lake and delta system. There are channels and deltas at the crater's edges, indicating that water once flowed there. These areas are perfect for finding organic molecules and microbial life traces carried by the water in the past. These features of Jezero Crater are the main reason why NASA chose to land the Perseverance rover there. Ancient lake beds and deltas on Earth are also sites where microfossils and other biological markers are preserved. Similar conditions are believed to have existed on Mars in the past. If life ever existed on Mars, we have a good chance of finding its traces in Jezero Crater. Additionally, carbonate minerals found in Jezero Crater excite scientists. These minerals could have formed through the action of water and the atmosphere, carrying chemical markers that support the presence of life. Now, let's take a look at what Perseverance rover is doing in this special crater. What is this advanced exploration vehicle finding on the surface of Mars, and what do these findings tell us? In the next section, we'll explore the tasks of the Perseverance rover and the technologies it uses. If you're ready, let's continue. Now that we know why Jezero Crater is so important, what exactly is the Perseverance rover doing there? How does this advanced exploration vehicle search for microbial life traces on Mars? Let's take a look at the missions of Perseverance and the technologies it uses. Perseverance rover is NASA's most advanced Mars exploration vehicle. Landing on the surface of Mars in 2021, this rover is equipped with a variety of scientific instruments and technologies, each designed to search for signs of life on Mars and understand the planet's past. Here are some of the key instruments carried by Perseverance. Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals. This instrument uses Raman and fluorescence spectroscopy to search for organic compounds and minerals on the Martian surface. These techniques are highly effective for detecting organic molecules and searching for signs of biological activity. PXL, planetary instrument for X-ray lithochemistry. PXL uses X-ray fluorescence spectroscopy to analyze the chemical composition of Martian rocks. This helps determine the elements on the rock's surface with high precision, aiding in the investigation of past water presence and biological activities. SuperCam. SuperCam is a laser device capable of analyzing rock and soil samples from a distance. the laser targets the sample, and the resulting plasma is analyzed to quickly and effectively determine the chemical composition of the Martian surface. MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. MOXIE aims to produce oxygen from carbon dioxide in the Martian atmosphere. This technology could be crucial for future human exploration missions on Mars. Using these instruments, Perseverance searches for microbial life traces in Jezero Crater. By examining the sedimentary rocks and delta regions of ancient lake beds, it confirms that water once flowed in these areas. It conducts chemical analyses of rocks and soil to find organic molecules and biological markers. Thanks to these advanced instruments, Perseverance is collecting data on Mars in unprecedented detail. This data helps us understand whether Mars was once a habitable environment and if microbial life ever existed there. So, what does it mean to search for traces of ancient microbial life on Mars? How are these traces found, and why are they so important? In the next section, we will answer these questions and explore the scientific foundation of the search for life on Mars. If you're ready, let's continue. Searching for traces of ancient microbial life on Mars is an incredibly exciting mission for scientists. But how do we find these traces and why are they so important? Let's delve into the scientific foundation of this search. The search for life on Mars is based on our knowledge of how life began on Earth. On Earth, microbial life emerged in places where water was present. Microorganisms lived in the depths of oceans, lakes, and rivers, and over time, they fossilized in sedimentary rocks. These fossils carry chemical traces of biological activity. Could similar traces be found on Mars? Jezero Crater is an ideal place to find such traces. Being an ancient lakebed and delta system, it indicates that water was once present there, creating the necessary conditions for life. Perseverance rover is searching for microfossils and biological markers in this region to investigate whether life ever existed on Mars. Microfossils are the petrified remains of ancient microbial life. On Earth, these fossils are typically found in sedimentary rocks. Perseverance rover is examining similar sedimentary rocks in Jezero Crater to find microfossils. These fossils could prove the existence of microorganisms that lived on Mars in the past. Biological markers are molecular traces formed as a result of the chemical activities of microorganisms. These traces can include organic molecules, lipids, and other biological substances. The scientific instruments carried by Perseverance are designed to detect these traces. For example, Sherlock and Pixel search for organic molecules and biological markers in rock and soil samples. Organic molecules are the building blocks of life. Organic molecules found on Mars could provide strong evidence of the presence of life. Perseverance is searching for these molecules in Jezero Crater, investigating the traces of life on Mars. The presence of organic molecules could indicate that life was once possible on Mars. Carbonate minerals are also of great importance to scientists. These minerals form through the action of water and the atmosphere and can carry chemical markers that support the presence of life. The carbonate minerals found in Jezero Crater indicate that water was present in the past, and therefore, life might have existed. The discoveries made by the Perseverance rover help us understand not only whether life ever existed on Mars, but also provide new insights into the origins of life on Earth. If we can find traces of life on Mars, it offers significant information about how widespread life might be in the universe. In the next section, we will look at the initial findings in Jezero Crater. What has Perseverance discovered and what do these findings mean? If you're ready, let's continue. Perseverance rover has made several important discoveries since landing on Mars. What are the initial findings in Jezero Crater, and what do these findings mean for the scientific community? Let's explore Perseverance's discoveries. After landing on Mars, Perseverance began exploring the surface, collecting various rock and soil samples. The initial findings confirm that Jezero Crater has a rich geological history and once contained water. The rover's scientific instruments analyze these rock and soil samples for organic molecules and biological markers. Perseverance uses various instruments to analyze the collected samples. For instance, Sherlock and Pyxel use advanced spectroscopy techniques to detect organic molecules and chemical components on the rock surfaces. These analyses indicate that the rocks in Jezero Crater hold significant information about past water presence and potential biological activity. The ancient delta and lake beds in Jezero Crater provide strong evidence that water once flowed there and that it was a habitable environment. Perseverance's examinations of these areas include analyzing the layers and minerals in sedimentary rocks. These analyses reveal carbonate minerals and other chemical traces formed by the action of water. These findings support the idea that Mars was a habitable environment in the past. One of the most exciting findings of Perseverance is the potential existence of microbial fossils. The rover uses high-resolution imaging and chemical analyses to detect microfossils within the rocks. These fossils could carry the traces of microorganisms that once lived on Mars. If these fossils are confirmed, it would be the first direct evidence of life on Mars. The initial findings of Perseverance in Jezero Crater have generated great excitement in the scientific community. The presence of water and potential signs of life on Mars offer significant clues about the prevalence of life in the universe. Scientists believe these findings could also provide new information about the origins of life on Earth. Now, let's look at the future missions of Perseverance and other discoveries to be made on Mars. How will the collected samples be brought back to Earth? And what does this mean for humanity? If you're ready, let's continue. The initial discoveries made by Perseverance rover in Jezero Crater have generated significant excitement in the scientific community. However, these discoveries are just the beginning. What comes next? Let's delve into the future missions of Perseverance and other research planned on Mars. One of the most important tasks of Perseverance rover is to return rock and soil samples collected from the Martian surface to Earth. This mission is part of the Mars Sample Return (MSR) mission. Conducted in collaboration with NASA and the European Space Agency (ESA), this mission plans to bring these samples back to Earth with a future spacecraft. Once on Earth, these samples will be examined in detail in laboratories, providing crucial information about signs of life and the history of Mars. Perseverance will continue to make deeper explorations in Jezero Crater. Particularly, sedimentary layers in the ancient delta and lake beds will be examined for microbial fossils and biological markers. The rover will move towards key targets identified by scientists, collecting more samples and storing them appropriately for future missions. The technologies used in the search for life on Mars are rapidly advancing. Following Perseverance, more advanced rovers and surface vehicles will be sent to Mars. These new vehicles will perform more precise analyses and explore different regions of Mars. Especially the polar regions and underground water reservoirs on Mars are seen as important targets in the search for life. In the future, sending humans to Mars is also planned. Organizations like NASA and SpaceX aim to conduct manned missions to Mars in the 2030s. These missions will focus on establishing permanent colonies on Mars and conducting more detailed explorations of the planet. Manned missions will be a significant step in the search for life on Mars and will accelerate scientific research. Discoveries made on Mars also increase international collaborations. NASA, ESA, Roscosmos, CNSA, and other space agencies collaborate on Mars explorations, combining their knowledge and resources. These collaborations lead to more comprehensive and detailed results in Mars research. These future discoveries and missions will enhance our understanding of the search for life on Mars and the planet's history. The missions of Perseverance rover in Jezero Crater are just the beginning of this great exploration journey. Finding signs of life on Mars will be a monumental milestone for humanity and will bring us a step closer to answering the question of whether we are alone in the universe. Today, we have explored the mission of Perseverance rover in Jezero Crater, searching for signs of ancient microbial life on Mars and the scientific significance of these discoveries. So, what have we learned at the end of this great exploration journey, and what do we expect in the future? Mars has always been a planet that captures humanity's attention in the solar system. With its ancient lakebeds and delta systems, Jezero Crater indicates that water once existed on Mars, and thus created suitable conditions for life. Perseverance rover, through its explorations in this special region, is collecting significant data about Mars's past and potential microbial life traces. The advanced scientific instruments carried by Perseverance analyze the surface of Mars, searching for organic molecules and biological markers. The initial findings confirm the presence of water on Mars and provide hope for the existence of microbial fossils in ancient lakebeds. These discoveries have generated great excitement in the scientific community and brought us a step closer to understanding whether life ever existed on Mars. In the future, the samples collected by Perseverance will be brought back to Earth and examined in detail in laboratories. These samples will provide deeper insights into the history of Mars and the signs of life. Additionally, new technologies and manned Mars missions will make it possible to explore the planet in more detail. The search for life on Mars not only helps us understand the planet's past, but also offers significant clues about the prevalence of life in the universe. If we find signs of life on Mars, it will show that we are not alone in the universe and that life can exist on other planets as well. This fascinating exploration journey affects not only scientists but all of humanity. These efforts to uncover the secrets of Mars will inspire future generations and allow us to continue exploring the unknown depths of the universe. If you enjoyed this video, please subscribe to our channel and turn on notifications to stay updated with our latest content. Also, share your thoughts and questions with us in the comments. Let's continue to explore the mysteries of Mars together.